All right, so today we're going to move towards an area where we start solving quadratic equations. Last couple of homeworks we've dealt with graphing quadratic functions, and we're still going to graph a little bit even with today's stuff and trying to solve a quadratic equation, but there are going to be non-graphing ways as well. So the object of today obviously is to be able to solve a quadratic equation. We'll talk about how to do that using graphs and how to do that using what's called the square root method. Okay, some quick vocabulary for you. To solve a quadratic equation, what does that mean? Well, it means there are a lot of terms that all kind of mean the same thing. If you're solving a quadratic equation, you're trying to find the roots. The roots of the equation are the same thing as the zeros of the function, which you're going to see in just a minute, why it's called the zeros. Another term for solutions are x-intercepts, because the solution of a quadratic equation or quadratic function is where the graph, which is a parabola, right, where a parabola crosses the x-axis. They're x-intercepts. But all these things mean the same. Roots, zeros, x-intercept. Anytime you're asked to find the roots, to find the zeros, to find the x-intercepts, we would do this the same way. And again, it's where the graph crosses the x-axis. We have to kind of think a little bit about what that means in terms of the coordinates if a graph is going to hit the x-axis. We'll do that in just a minute. Okay, so there are three different situations for parabolas, and they're here. And based on the particular situation, it should let you know how many solutions you would expect a quadratic function to have. The first situation is when the vertex is below the x-axis, so down here, and opens up, or if the vertex is above the x-axis and opens down. In either case, how many solutions is that function going to have? Well, again, the definition of a solution is where the graph crosses the x-axis. And so since this guy crosses here and here, there are two solutions. And for this particular quadratic function, the solutions would be 1 and -1. Okay? Here, in the second situation, where the vertex is on the x-axis, it can open up or it can open down. It doesn't change the fact that there's only going to be one solution. There's only one point on the x-axis. And here, that solution is at 1. The third and final situation is if the vertex is above the x-axis and opens up, like this, or if it's below the x-axis and opens down, like this. In either case, the graph is not touching the x-axis at all, and so therefore this is not going to have any solutions at all, and so we would just talk about this particular quadratic function having no solution. Okay? Now, I mentioned before that solutions are also called roots, which are also called zeros, which are also called x-intercepts. Now, it's easy enough to see why they're called x-intercepts is because this graph hits the x-axis. Why they're called roots is a whole different conversation. Why they're called zeros makes a lot of sense, because the coordinates for these points, 1, 0, -1, 0, it's the y coordinates are zeros. And the y's always give us the value of the function at a particular x. Okay? So, at a solution, the value of the function should be 0. That's why these things are called zeros. The y coordinate should be 0. If we're going to look for solutions, then what we're looking for is where the y is going to be 0. And we're going to use that idea in just a moment as well. Okay? For example, here. In your notes it may look different, but go ahead and change this over to a function, which is y equals x squared minus 9. Now, we can solve this by graphing. All we got to do is graph the parabola and find out where it hits the x-axis. So we've been graphing parabolas for the last couple of classes now. We know that this guy's going to open up because a is positive. The vertex, we find the x-coordinate by going opposite b over to a. Opposite b is going to be 0 because b is 0. There's no x to the first term. 2 times 1, so this is still going to be 0. So we're going to be at 0 for the x value. If we plug in 0 for x, this is going to be 0, and so y is going to be negative 9. The axis of symmetry is always x equals whatever the x-coordinate is, which is x equals 0, because the vertex here is at 0, negative 9, and the axis of symmetry goes through the vertex and cuts the u in half, the parabola in half. So that's your axis of symmetry line. Now to graph this, we're going to choose two x's on the same side of the axis of symmetry. So I'm going to choose 1 and 2. You plug in 1 for x, you get 1 squared minus 9, which ends up being negative 8. Plug in 2 for x, you get 2 squared minus 9, which ends up being negative 5. So we go 1 common negative 8, which is here. 2 common negative 5, which is here, and then we mirror image this. And then we're supposed to draw our parabola. And then we're supposed to tell where the solutions are. Well, as you can see, my graph was very quick and not really accurate. So while you can look at that and see that it's going to hit the x-axis in two places, it may not be very easy to see where. But I do see that as I move over an x value, I get the y keeps going up, right? So we went over 1 on the x-axis and then went up 1 here, and then we went over 1 and went up 3. So I wonder if I went over 1 more. If I chose 3 as an x value, what would happen? Well, I'd get 3 squared minus 9. Well, 3 squared is 9. 9 minus 9 is 0. Remember what we said. If the y value, if the y-coordinate is 0, then this should be a solution. This is going to be an x-intercept. 3 comma 0 is right there. So that's a solution. So 3 is, and because this is symmetrical, because the parabolas are symmetrical, we know that on the other side, we should be hitting at negative 3. Now that's only because the axis of symmetry is the y-axis. But regardless, if we plug in negative 3 for x, we would get negative 3 squared minus 9. Negative 3 squared is 9, minus 9 is 0. So there's another 0. So our zeros for the function are at 3 and negative 3. So our solutions are at 3 and negative 3. Okay? All right. Now, that's the graphing method, and as you could see, the graphing method's not real accurate. It's not very easy to do. It's not very easy to find the solutions. So we do have other methods. It's a lot like solving systems. When we solve systems of equations, the graphing method was our least favorite because it wasn't really accurate and wasn't very easy to do. So we do have another method here called the square root method. Now, the square root method only works when b is 0, like it was back here. Right? There was no x to the first term, so b was 0. This square root method only works for them. Now, the square root method says we got to get x by itself, take the square root of both sides, and then make sure to include plus or minus with your answer. Now, here's the deal. Our function, if b is 0, our function is going to look something like this. Okay? Now, again, we call these solutions zeros because this is where y would be 0. This is where the y-coordinate would be 0. So what we do is we replace the y with a 0 in the function. Okay? Because we already know that y should be 0 at that solution. And so we end up with an equation that we can solve. We get x squared by itself. We square root both sides because square rooting is the inverse of squaring. And as we saw in the last example, we include plus or minus in our answer because we know that our x-intercepts could be positive and or negative. So if we were to do that for this function over here, we already know the solutions are 3 and negative 3. So if I didn't want to graph this, if I wanted to use the square root method, then I would take this function and I would plug in 0 for y. Because again, we're looking for we're looking for solutions which are zeros for the functions. We plug in 0 for y, and then we get x squared by itself. To do that, we add 9 to both sides. And so we get 9 equals x squared, and then we square root both sides. And we find out that x is equal to plus or minus 3. Okay? And that's what we found out up there. So it does the same thing. Whether we're graphing or we use the square root method, we should come up with the same solutions. All right? So we're going to plug in 0 for y, and then get the square root by itself, get the x squared by itself, square root it, and then make sure that we use plus or minus. Right? So there's some examples for you. First one here. So you have to imagine that this starts off as a function where y is equal to 2x squared minus 32. And we're asked to find the solutions. We're asked to find the zeros. We're asked to find the roots of this function. So we're going to plug in 0 for y. And then we go solve the equation. We get the x squared by itself by adding 32 to both sides. And then we divide by 2. Then we square root both sides. The square root of 16 is 4, but we know that it could be positive or negative 4. Because we know that we could possibly have two solutions, plus the square root of 16 has to be a number when it's multiplied by itself that will give you 16. Positive 4 times positive 4 is 16. Negative 4 times negative 4 is 16. So it's got to be plus or minus. Okay? Now, same thing for number 2. Subtract 108 from both sides. You get negative 3x squared equals negative 108. Divide by negative 3. And x squared is equal to 36. Then you square root both sides. And you get plus or minus 6. Okay? Now, think about what that means. If the solutions are, number 1, the solutions are plus or minus 4. So if we graph this function, what would you be able to tell me right now? Well, hopefully you'd be able to tell me that the parabola that we get is going to hit the x-axis at plus and minus 4, at positive and negative 4. 2 points on that graph would be 4, 0 and negative 4, 0. All right? Same thing for number 2. If we graphed that function, and again, you have to imagine that this is a function because we've replaced the y with 0. So if we graph that function, then that parabola would hit the x-axis at positive and negative 6. Okay, that's what we're doing here. We're trying to find out what the solutions are. We're trying to find out where the parabola will hit the x-axis. All right? All right, there's 2 more here for you to try. Knock these out and then start the video back up and see if you got them right. And I warn you, they're a little tricky. They introduce a kind of a new concept. But try them out, see if you remember what you're supposed to do with them. And you should have gotten this. In number 3, you subtract 50 from both sides, divide by 2, and you get negative 25. But when you square root both sides, you can't take the square root of a negative number. If you don't believe me, type that into your calculator. Type negative 25 into your calculator and then square root it. And I promise you, your calculator will say error. Okay? That is a situation where there's no solution. Okay? If there's no solution, what do we say? That must mean that the parabola is not going to cross the x-axis. It's not going to touch the x-axis. And since the A is positive, which means that the parabola opens up, then the vertex must be above the x-axis. So these solutions kind of give us some insight into the graph as well. Now, number 4, we subtract 25 from both sides and divide by 5, and we end up with x squared equals 0. But when we square root 0, we just get 0. I mean, plus or minus 0, but those are the same number, right? So you actually only have one solution. If we only have one solution, that must mean that the vertex is actually on the x-axis at x equals 0. Okay? So that's a situation where you're going to have one solution. All right? All right. Last guy here, there's a story problem. An aquarium is designing an exhibit to showcase tropical fish. The exhibit will include a tank that is rectangular prism with a length L that is twice the width. L that is twice the width. So L is equal to 2 times W. The volume of the tank is 420 cubic feet and the height of the tank is 3 feet. What is the width of the tank to the nearest tenth of a foot? Okay? All right, well, how do you find volume? Volume is length times width times height. The volume is 420 cubic feet. The length we don't know. But we do know it's twice the width. So I can let L be 2W. The width is W, and the height is 3. And so we need to just go solve this equation. So 420, 2W times 3 gives you 6W squared. Divide both sides by 6, and W squared is equal to 70. Square root, and W is, and we're going to go ahead and square root 70, because that's what's going to make the most sense, and it gives you plus or minus 8.4 feet. But can anything be negative 8.4 feet long or wide? The answer is no. We don't talk about it like that. So while it is plus or minus, we know that the negative side doesn't make any sense. So the width of this tank must be 8.4 feet. Okay, just a quick application of this square root method to solving a quadratic. All right, that's it. Homework's out in Canvas. Make sure you have it done by next time.